So today's going to be good. It's going to be like a summary of things we've done. We're not going to get, this is our only new situation. If you can do this one really well with your partner, you're going to be all set for the homework check today, okay? So let's set up our premise. There's Claire. Claire's into bread, okay? Claire's opening up this bread. Can't wait to make this sandwich. It's only one slice, so she has to do that half sandwich thing. You know, you can take one slice, cut in half, then you got a half sandwich.
Never done.
But she doesn't even get that. It was the butt end too. You know, I don't care, but some people care. And it's got a 1 cubic millimeter section of mold on it. It's got a little green and a little white in it. It's one of those double molds, okay? And she's like, well, let's see what happens. So she noticed the next day the amount of mold doubled. And the next day it doubled, okay? It doubled so much she called it iron. That's what she named her slice of bread. I know what you're thinking, Josiah. If I name my slice of bread, it would not be Ireland. But
who does that?
so if this continues, you need to figure out how much bread is covered by mold 4 days later. You need to represent the relationship between the area in square millimeters and the number of days using a table of values, an equation, and a graph. You are then with your partner going to write a function statement for number 6. We got a lot to do. This is taking everything we know and putting it in one. Let's get it moldy, baby. All right, y'all. Let's do it to it. So for number 1, if the doubling pattern continues, how many millimeters will I have after 4 days, and how do you know? Okay? 16 what? How do you know? You doubled it every day. I personally am going to go
Doubled every day
after. Well, it doesn't double the first day, right? So I've got area and I've got days. I would go right to a table somewhere, probably like 0 days. It was 1, 2, 3, 4, and then it was 2, 4, 8, 16. Okay, something like that. Now, 2. What's our equation that we're going to use? Magic?
A equals 1 times 2 to the power of d.
Yeah, I like that. My starting value is 1 millimeter. It's doubling. D times. A repeated multiplication is my exponent. So I answered all those questions, right? Reasoning, 2 days. Oh, my table's supposed to go through 5 days, but I ran out of room. 5 days would be how much? 32. There's an extension on my table. And then I need a graph. I only have room for a little guy here. 2, 3, 4, 5 days. 5, 10, 15, 20, 25, 30, 35 maybe? Anybody use the same scale by chance? Nice. Okay, so started at 1, then went to 2, then went to 4, then went to 8, then went to 16. Oh, it's about to take off. Now, in terms of practicality, will it keep doing this? Will it keep doing that forever? It's going to run out of bread unless you really love your fungus and you're going to give it some more bread maybe.
A pet?
Pet fungus. Ooh. People used to have pet rocks. Maybe we could talk people into pet funguses. Us pet fungi. Okay. So we got an equation. We got a graph. It looks very exponential. Who can help me out with a function statement for my function here? Ivy? Yeah, I'm going to just use less words, but same thing, yeah. The area of the mole is a function of the days. The days determine. Imagine how messed up the world would be if the area of mold on this piece of bread changed which day it was.
You might be a fun guy, but I must be
Could be cool. We've already seen them before. We got bacteria, we got card depreciation, we got algae blooms. We got it all. Maybe this is the all-star game of cool exponential functions. Okay?
Oh, Miles Garrett?
For all 3 of them, you're going to do the bullets. The bullets are a sentence, blank is a function of blank. You're going to indicate the independent and dependent variables, and then you're going to write an equation that matches the function. I've kind of been having you do the equation already, so that part should be kind of nice. So, all 3 bullets, all 3 situations with your partner. Here we go. In a biology lab, we got these bacteria. Who can give me the blank is a function of blank statement? Zeph?
The bacteria is a function of hours.
The number of bacteria is a function of the time in hours, okay? So, time is independent, bacteria is dependent. Who can help me out with that function? Sean?
Bacteria is dependent on the hours.
Okay, yep. So what's the function that you got written for it?
Oh, you mean the equation?
Yeah.
Oh, okay. A equals 50 times half to the H.
Okay, so I like what you did. It's split, so you're like half. But when they split, what happens to the number of bacteria?
Oh, no.
So this is a great mistake. So our growth factor is times 2. That's a good mistake.
I did
Split
do the second
system.
challenge.
And then I need an exponent. How many times is that going to happen?
Yeah,
Every hour, so maybe H. All right.
Why don't you use the same variables?
Who can put it in a function sentence for me? Let's go with JP. Car value is a function of years. I'll take it. Which means years, the time is independent. The price is dependent on that. And I need some help with a function here. Zeph?
A little sweet.
X equals 18,000 times 203.
Yeah, let's do y equals instead of x equals. But yeah. So this one's a little tricky, right? It loses a third of its value, so how much is left?
2/3.
2/3. You need a 2/3 there. If you put a 1/3 there, good mistake for now.
I put V
With your
equals
son,
7,000.
I had Z.
Because if you're changing the...
So our independent variable is going to be the x, the input, right? So you told me the independent variable is yours. And
I put V equals for
yeah, if you have different letters, it's all right. We just did x and y. And last, this algae bloom. It's happening again. Who can put this in a function sentence for me? Maddie?
the amount of algae is a function of time.
Algae area is a function of time, which means time is independent, and the algae area is dependent on that time. Caleb, can you hit me with an equation?
V equals 18,000 and 2.
Oh, we're on number 3.
I didn't get that.
Okay, well, let's do it right now. We got this. So I'm going to give you this. A for algae bloom. How do I get my algae bloom? What's my starting amount?
240.
240. What's it doing?
Third of it.
So a third's left. So this one stays a third, right? You guys seeing that?
Yeah.
This one stays because there's a third left. It's losing 2/3. Okay, then what's my exponent? T or time. There we go. Cool.
I did it before you got done.
There it is. That's all we need in this lesson, friends. We know a lot about exponential functions now.